Welcome back. In this module, you will be introduced to data modeling concepts and the process of building data science model. Data modeling concepts. In this section, we will discuss what is data modeling and why it is essential to data science. Data modeling is a method of defining and organizing your company's processes. By studying, comprehending, and explaining your data requirements and how they support your business activities, you may generate a visual depiction of your business. Data models are technical in nature, but also designed to be visual and simple. It aims to help people in an organization understand and collaborate with data more effectively. Data modeling is a crucial skill for every data scientist, whether you are doing research design or architecting a new data store for your company. The data modeling component of data science is all about the ability to think visibly and logically about the key data points to be kept and retrieved, as well as how they should be arranged. With data modeling, business users can have a direct hand in defining core business rules, which means fewer revisions are needed at implementation time. It articulates business and its processes and allow collaboration among data scientists and stakeholders, thus uncovers the data and its relationships, which provide a foundation of understanding your business processes and how to improve them. Data models give meaningful diagrams of your data processes, so you have a full visibility into your data architecture. It also makes the sophisticated, highly technical components of your organization more accessible to less technical staff members, such as business executives and those in the C-suite. Data modeling also makes it easier to integrate high-level business processes with data rules, data structures, and the technical implementation of your physical data in a way that everyone can understand. Data models bring coherence to how your business functions and uses data. Like any design process, data science design process begins at a high level of abstraction and becomes increasingly more concrete and specific. Data models can generally be divided into three categories, which vary according to their degree of abstraction. The three stages or types of data model called schemas are as follows. Conceptual data model. They are also referred to as the domain models and offer a big picture of the scope of the system, how it will be organized, and which business rules are involved. Conceptual models are typically generated as part of the early project requirements gathering process. Logical data model. They are less abstract and provide greater detail about the concept and relationships in the domain under consideration. One of several formal data modeling notation systems is followed. These indicate data attributes such as data types and their corresponding length and show the relationship among entities. Technical system specifications are not specified in logical data models. Physical data models. This schema is less abstract and provides how the data will be physically stored within a database. They offer a finalized design that can be implemented as a relational database. Database Management System or DBMS specific aspects such as performance tweaking can be included in physical data model. There are many possible visual representations of data models, but the primary one used in database design today is the classic entity relationship model. This is simply a flowchart of boxes describing entities with their attendant data points inside, and lines between the boxes describing the relationship between entities. Modelers might find themselves using other specialized modeling methodologies on specific projects. However, and data scientists will be expected to learn several of them, including Batchman diagrams, object role modeling, and Zachman frameworks. Building a data science model. In this section, you will learn what data science models are and how to build one. The term data science and modeling are widely used to describe the process of solving complicated problems. Every data scientist should be proficient in data modeling since it allows businesses to make data-driven decisions and achieve a variety of business objectives. Data scientists develop various models in performing the following activities. Problem structuring. Understand the business logic of how to use data for business problems. Model business rules and processes. Create workflow of how data works and optimize it. Verifying data quality. Validate data quality and use tools like natural language processing or NLP to get the probability of error, identify patterns, trends, and anomalies. Identify new data sources. Know the value of data and how to utilize it. Build a business model using data rules to optimize targets. Problem structuring is a very important skill of a data scientist. A good data scientist can not only comprehend the business problem, but also draw a diagram of data and business activity related to the business problem's key performance indicator or KPI. In the area of data science, solving problems and answering questions through data analysis is a typical practice. As mentioned, data scientists construct a model to predict outcomes or discover principal patterns and gain insights. During the modeling stage, data scientists could sample data sets and find the optimal model for the given data after data preparation. In what way can data be visualized to acquire the appropriate answers? Modeling addresses the question. When the model is evaluated, it is asked, does it answer the initial query or does it need to be refined? The modeling stage focuses on creating descriptive or predictive models. These models are based on an analytical approach which can be statistically or machine learning driven, depending on the situation. With predictive models, data scientists use a training set or a historical data in which the outcome of interest is known to build the model. The modeling process is typically highly iterative as organizations gain intermediate insights, leading to refinement in data preparation and model specification. In John Rollins' descriptive data science methodology, the framework is geared to do three things. Understand the question at hand, select the analytical approach or method to solve the problem, and obtain, understand, prepare, and model the data. The final phase of data analytics is significantly easier if you follow the three steps. Analytics might include a statistical model to reflect a business model. or it can simply be a dashboard or visualization, depending on the situation. A key to success in finding the right analytical technique is to start with basic descriptive statistics and then move on to the predictive modeling. Predictive modeling and data analytics. This section will provide introduction of modeling techniques used in data analytics. Predictive modeling, also referred as predictive analytics and machine learning, is a process that uses data and statistics to predict outcomes with data models. However, predictive analytics most often refers to commercial applications of predictive modeling, while predictive modeling is used more generally or academically. Machine learning is defined as the application of statistical techniques to allow a computer to develop predictive models, which is distinct from predictive modeling. The terms are frequently used interchangeably in practice. Forecasting is possible with predictive modeling because it provides correct insight into any subject and allows users to make forecasts. It is vital to have insight into future events and outcomes that challenge core assumptions to sustain a competitive advantage. Types of data analytics. There are 4 types of data analytics we encounter in data science: descriptive, diagnostic, predictive, and prescriptive. Descriptive. Insight into the past. What is happening? This is the most common of all forms. In business, it provides the analyst a view of key metrics and measures within the business. Descriptive analysis or statistics describe or summarize raw data and make it something that is understood by people. It's important to employ descriptive analytics because it allows us to learn from past data and see how it can influence future outcomes. Diagnostic. Why is it happening? Diagnostic analytics is the why behind descriptive analytics. In data analytics, this is the next level of complexity. Diagnostic analytical tools will enable an analyst to go down and find the root cause of an issue based on the descriptive data. On assessment of the descriptive data, diagnostic analytical tools will empower an analyst to drill down and in so doing, isolate the root cause of the problem. Well-designed business information or BI dashboards, incorporating reading of time series data, such as data over multiple successive points in time, and featuring filters and drill-down capability allow for such analysis. Predictive. Understanding the future. What is likely to happen? Predictive models are used to determine the likelihood of an event occurring in the future, anticipate a quantifiable amount, or estimate a point in time when something might occur. Predictive models typically utilize a variety of variable data to make the prediction. Predictive analytics has its roots in the ability to predict what might happen. These analytics are about understanding the future. Predictive analytics provide companies with actionable insights based on data and provide estimates about the likelihood of a future outcome. Prescriptive. Advice on possible outcomes. What do I need to do? The next step up in terms of value and complexity is the prescriptive model. The prescriptive model develops an understanding of what has happened, why it has happened, and a variety of what might happen analysis to help the user determine the best course of action to take. Prescriptive analytics aim to quantify the impact of future decisions to provide recommendation on likely outcomes before they are taken. Prescriptive analytics, at its best, predicts not just what will happen, but also why it will happen and makes suggestions for action that will benefit from the forecast. The table shows a comparison between predictive analytics and descriptive analytics with an example. You have come to the end of Module 5, Data Science Model. Here are our takeaway points from this module. Every data scientist should be able to model data. The data modeling component of data science is all about the capacity to think clearly and systematically about the main data points to be saved and accessed, as well as how they should be categorized and related. In the data science framework, solving problems and answering questions through data analysis and constructing different types of models to predict outcomes or discover principal patterns and gain insight is a standard practice. We'll talk about numerous data science applications in the next module. Thank you for completing this module, and we look forward to seeing you in the next one.